Hello, ladies and gentlemen, welcome to Malo Tutorials. In this video, we are going to learn on how to make a frequent distribution table as well as with the relative frequency. So, we are given a statement here which is saying, the following data shows the number of workers employed by Chino University of Technology. So, this is the workers employed at University of Technology. And then the question is saying, use the stage rule to convert the above data into group data and present it in a frequency distribution as well as the relative frequency. So here our question is different from the last one. This one is saying you need to use the stage rule. We are not given the number of classes here. So there are steps which you have to follow in order to draw this frequent distribution table and the relative frequency. So the number one step. Step one, we need to calculate the range. And then from this data, we know, let us first write the formula. The range is equal to the biggest number. The biggest number minus the lowest number. And then from this data, our biggest number is 48. Minus our smallest number is 13. So our range is equals to 35. And then the step 2, we need to calculate or to determine the number of classes. So this is where we are going to introduce the stage formula. So the stage formula says that k is equals to 1 plus 3.22 log n. N is equals to the total number of the data points. So our data points here, we are going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So we have 30 data points. So we are going to write 30 here on n. So we are going to say k is equals to 1 plus 3.22 log 30. So if we find on our calculator, 1 plus 3.22 log 30 is equals to number of class going to be 5.756. So as I said earlier on the other video, that if we get the number of classes with a decimal, we are going to round off this first digit to the next whole number. So here we are going to round off this 5 to 6. So here when rounding off, we are not using the rounding off rule. We just round up as long as the number is a decimal. Let's say if the number is 5.001, we will round it. We will round this digit to the next whole number. So without considering the rounding off rule, as long as the answer we get here on the number of classes is a decimal, we round this first digit to the next whole number. So let us go to the step 3. On the step 3, we need to calculate the class width. From this data, the class width, the class width formula is equal to range divided by the number of classes. And then from this data, our range is equal to 35. And then the number of classes is 6. And then our answer is going to be 35 divided by 6. Our answer is going to be 5.883. 5.883. So as well as with this class width, as long as we get it as a decimal, we have to round off this first digit to the next whole number. So it means that the class width and the number of classes, we don't have to seal them with commas, or we don't have to seal them as decimals. So we have to round off those numbers to the next whole number so that we left them as the whole numbers. So here we are going to round off this 5 to 6. So it means now the class width is 6. So after completing these steps, these 3 steps, we are going to draw a table for a frequency distribution table, which is showing our frequency distribution table. So the first column, so we are going to have 3 columns for the class interval, and then tally, frequency. This is the columns for the frequency table. And then the question is saying as well as the relative frequency. So we are going to add the 4th column for the relative frequency, which is RF. So now these are going to be our columns. So then on the number of rows, how many rows are we going to have? So we come back here on the number of classes. The number of classes is the one that determines the number of rows which are going to draw here. So we find out that we're having 6 as our number of classes, meaning to say we are going to have 6 rows here. So let's start. 1, 2, 3, 4, 5, 6. So these are the number of rows which are going to have here. Yeah. So now after completing our table, we know that on the class interval we're having 2 parts, the lower class limit party and the upper class limit party. So here our first lower class limit here, we are going to take the smallest number. So we've already found out that the smallest number is 13. So this is going to be our first lower class limit. And then to find the second lower class limit in the second interval, this is where we are going to use this class width. So we are going to take the class width and then we add here on the first lower class limit. So if we add 13 plus 6, we are going to get 19. And then to find the next again, we're going to add again the class width. So 19 plus 6. To find the third lower class limit, we are going to find 25. Then 25 plus 6 is 31. 31 plus 6, that's 37. 37 plus 6 is 43. So these are the lower class limit or the lower class boundaries. And then to find the upper class limit or the upper class boundaries, we are going to come here on the second lower class limit, and then we subtract this second lower class limit by 1, so that we'll be able to find the first upper class limit. So we'll be saying 19 minus 1, and then we're going to get 18. So 18 is our first upper class limit or our first upper class boundary. And then to find the second one, we're going to add the class width. So we're going to repeat this process of adding the class width. So we're going to say 18 plus 6 is going to be 24. 24 plus 6 is 30. 30 plus 6, 36. 36 plus 6, 42. 42 plus 6, that's 48. So now we are done with finding out the class intervals. So after completing the class intervals, we are going to calculate for the frequencies. So for the frequencies, we are going to say the numbers in between 13 to 18. How many numbers are we having? In between from 13 to 18, we are having 13. And then we are having 18. And then we're also having we're also having 18. So these are the numbers in the range of 13 to 18. So these numbers, now you count, that's the frequency. You count 1, 2, 3. So 3 is the frequency. Then 19, in the range of 19 to 24. Which numbers are we having? We're having 19. And then after 19, we're having 21. And then we are also having 19. And then we're also having 21. And which one? We're having 24. And this 24. And then now we count these data points 1, 2, 3, 4, 5, 6. So our frequency 6. Then repeat the process 25 to 30. 25 to 30. We're having 30. And then after that, we're having 25. And 28. So here, the frequency is 3. Then in between 31 to 36. Which numbers are we having? We're having 35. 32. 33. 31. 33. 33. And then 32. So that's all. And then that's 1, 2, 3, 4, 5, 6, 7. So we're having 7 here. And then between 37 to 42, we're having 37. And then we're having 39. having 38. Then our answer is equals to 3. So we just repeat the process. So now we have also to count this one to the ones which left are for 43 to 48. So now let's go and fill in the frequency. So on 13 to 18 we find out the frequency. It's the frequency 3, and then for this one it's 6, then 3, 7, 3, and this one the left one 1, 2, 3, 4, 5, 6, 7, 8. Or this 37 was supposed to, or is supposed to be here. It's correct. So here we're having 8. This one's having 8. To confirm if the frequency is correct, we need to add up all this. After adding up all this, they must be equal to the data points we are having to that end. So we are going to say 3 plus 6 plus 3 plus 7 plus 3 plus 8. So we're going to get 30. So it means it's correct because we have counted the number of data points and we found out it's 30. So if we add this frequency and it come out as the same as this the number of data points, it means it's correct. Now on drawing the tally, we're going to say 1 2 3 1 2 3 4, then the 50 6 1 2 3 1 2 3 4 5, then 1 2 7 1 2 3 1 2 3 4 5 6 7 8. So this is how we draw the tally. So the tally is just simple. And then on determining, now we need to determine the relative frequency. How do we determine the relative frequency? So the relative frequency, the relative frequency is equals to, we're going to say the relative frequency is equals to, we say the frequency divided by the number n, the n. So we're going to say 3 divided by 30 to find out the first relative frequency here. So the first relative frequency, if we say 3 divided by 30, we're going to get 0.1. Sorry, 0.1 is 0.1. And then if we say 6 divided by 30, say frequency divided by n, then the total number of the data points, so say it's called 0.2. And then 3 divided by 30 is 0.1. We've already get the answer. And then 7 divided by 30, it's 0.23. And then here it's 0.1. Then 8 divided by 30, it's 0.2666. So it's going to be 0.27. So this is how you calculate for the relative frequency. If you want to confirm if the relative frequency is correct, we have to add all these relative frequency points. All these relative frequency points must be equal to 1. So if we add 0.1 plus 0.2 plus 0.1 plus 0.23 plus 0.1 plus 0.27, the answer is 1. So it must be equals to 1 if the answer is correct. So this is how you'll draw the frequency table using the stage rule as well as the relative frequency. So thanks for watching, guys. Don't forget to subscribe, like and share. Bye bye.